Hi, Assalamualaikum. My name is Ahmad Faid bin Saiti and I am from KSF1. Today I will present to you about carbocation. So, what is exactly carbocation? The carbocation is exactly a carbon and cation. The carbon is carbon and cation is positive charge. So we can easily give the definition is a carbon with a positive charge. So usually carbocation is reactive and short-lived. So we can find them immediately in reaction. Carbocation is trigonal planar because it is sp3 hybridized. So we can see this form. It forms trigonal planar. Okay. So in carbocation, the p orbital contain no electron. So the p orbital carbocation contain no electron, but the p orbital can accept electron when the carbocation undergoes further reaction. Now we are going to discuss about the reducibilities of carbocation. So as we know, carbocation is the most stable is tertiary carbon, and then secondary, and then primary, and lastly we have methyl. So the most stable carbocation, the faster of SN1 reaction. So we know that carbocation is related to S1 reaction, right? So why tertiary carbocation is the most stable? So the main reason why is the tertiary carbocation is the most stable because they have 3 carbon at the carbocation. So we can see that secondary they have only 2 and the primary they have only 1. So this is the reason why the methyl is the least stable in the carbocation. Okay, so we can see that they have 3 carbon here. So the carbon they will push the electron towards the carbon here, and they will use the positive charge to make them stable. So when it's stable, it will use the lower energy. So this is the reason this is the most stable. So we can call this as inductive effects stabilize the carbocation here. So we can see that here we have 3 sources, here 2 sources, and here only 1. As we can see here, this is actually the inductive effects. The inductive effects will stabilize the carbocation. So we can see here there is 3 sources. 3 sources push the electron towards the carbocation here. So the secondary only 2 and the primary only 1. Okay, so now we are going to talk about the resonance effects stabilize the carbocation. At the previous, we talked about the how the inductive effects CH3 stabilize. The more we get the alkyl group, the more stable. Like the tertiary carbocation is the most stable. So now we are going to talk about the how the resonance effects stabilize carbocation. So which is the best at stabilize the carbocation? So I can see that we can all agree that the hydroxy group can better stabilize the carbocation. The reason is why? Because oxygen have 2 lone pair. They have 2 lone pair, so they will donate a pair of electron to the carbocation by resonance effects. So this is what we call the resonance effects. So they will donate a pair of electron here. So when the oxygen donate the electron to the carbocation, so it will form a new bond here. So the carbocation here can be stabilized. So the carbon here is stable. Why I thought it's stable? Because as we can see here, the carbon atom here is neutral, no charge. So it is obey the Otet rule. As you can see here, the carbon here have 4 carbon surrounding here. eh, they have 4 bonds surrounding here. 1, 2, 3, 4. So as we can see that here, they have no resonance effect. So because you can see here, the carbon here has 3 bonds and 6 electrons, which is not always the octet rule. So this is the main thing. So this is the resonance effect. For the next question is, which is the better can stabilize the carbocation? So which is your answer? So the answer is exactly the fourth one here. Why? Because we will look this one by one. Okay, for the first, this has no anything to stabilize the carbocation, so it will remain the same. So for the next, we have a double bond here, so we can do the resonance structure. So for the resonance structure, it's better to have to share the 2 carbon. It's best to share a positive charge with 2 carbon than 1. So here we're gonna do here, and then the charge will become the carbon bond will be here, and the positive charge will be here. Okay, so for the next, they have 2 double bond. Okay, next we have 2 double bond here. So as we can see here, okay, so the positive charge here can jump 2 carbons as it moves towards the carbon. Okay, as we can see here, the positive charge can jump 2 electrons as it moves around the structure. Okay, as we can see here, same like here, it will jump here, so the positive charge will be here, like this. And then when the jump here, so positive charge will be here. So here, and then this will jump to this here, and then it will become okay. So the temperature occur here. As I thought earlier, this is the most stable because why? First, we can put the positive charge here to the nitrogen. Okay, the way is as usual. Put this toward this, and then it become this. The positive charge will be here, and then we can put the lone pair. We can make a new bond. So as we can see here, the nitrogen have 2 lone pair. So with these 2 lone pair, they will form a new bond here. So it will become like this. Nitrogen here, and then the double bond here, and then the positive charge will be at nitrogen atom. So this is the resonance structure, and it will stabilize. The most stable is with the nitrogen atom. Why I thought this is the most stable compound? Because firstly, as we can see here, the all bond complete the obeys the octet rule. And the second, as you can see here, the pyridine look like the benzene ring. As we know, the benzene ring is the most stable compound. As we can see, the pyridine is look like benzene. It look like benzene ring. So we know that benzene is the stable compound.